All right, calculus students. This week you had a test. I'm assuming that went really well for you. Congratulations. The other piece that we need to look at is we got to look at your assignment, and it's going to be to do a Riverwind paired assessment. So, for example, you guys are all getting credit through Riverwind for this class, and got to adjust something here, but as you guys get credit for this class, the fact is that there's certain things that we have to do to stay in compliance with Riverwind. Really, their accreditation. These are the things that allow us to transfer, allow us to get proper funding for this class, and everything like that. So there's a few business items that we need to take care of. Sorry, I had to adjust the camera there a little bit. All right, and one of them is this kind of paired assessment. So teachers, we give the same kind of practice test or whatever, and we just check to see how kids did. It's not going to really affect your grade, but I'll show you what you need to do. It'll be counted towards homework, and it'll be 10 points, just like a normal assignment. It'll be based off completion, okay? So it's multiple choice for the first 10 problems. The 11th problem you work on your own. So the others are just multiple choice, answer A, B, C, D, or I think some options have E. Do it on your own. Don't partner up. Do it without the help of notes and stuff. Just do your best. If you score 5 out of 11, then you get 5 out of 11. You get, but I'll give you 10 points for completing, okay? Number 11, do by hand. So that's going to require some handwritten work. It's not multiple choice. And then after you go through it, you're going to grade it on your own. So I'll have a document that will say, here are the answers and here's how you scored. All the first 10 problems you score either right or wrong. And then problem number 11, you score from 0 to 5, depending on how well you did on the last problem. And then you can just submit your results via a Google form. Okay, so normally in class at this time, so there'll be a Google form posted. You just click on that and you just enter in your results. Did you get problem 1 right, 2 right, 3 right, so on and so forth. And again, don't make a big deal out of it. Try, pay attention to this review. We're going to just do a slight review of some topics throughout the year. Nothing real big, but just kind of a general idea that we would do before we did something like this. So the first one is just, kind of discussing limits. I know you remember kind of the basic idea of limits, but the question is, if A is here, does the limit as x approach A of the function, does that exist in this situation? Does the limit exist? And the answer is it does, because the limit is the same from the left as it is from the right. So the limit exists in this situation, okay? If we change that a little bit, suppose that we went like this, and we went like that. Does the limit exist? No, it doesn't. It's different from the left than it is from the right. So you have a limit from the left, that exists. Limit from the right exists. But the limit as a whole doesn't exist because it's different. Suppose we had a picture that looked like this. Does the limit exist? Yes. It's the same from the left as it is from the right. Is it continuous? No. It's got a discontinuity right there. You can't take the derivative right there either, but it's it's got the same limit. So same limit for left and right, so limit does exist. And then we could have a situation that looks like this. Does that limit exist? And in fact, it doesn't. Different from the left than it is from the right. It's not continuous either. Differentiable, no. So that's something you have to consider regarding limits. So limits, you can check using your calculator. You can make a graph, stuff like this. You can use a calculator on this one, okay? So in case you need to check stuff. Another limit I'd like to talk about is a really important one. Limit as x goes to infinity. Let's say you're looking at limit as x goes to infinity of 3 minus x over 2x plus 4. And in this situation, remember we factor out that x. So we get the limit as x goes to infinity of, we factor out an x, and we get 3 over x minus 1 over x times 2 plus 4 over x. And remember, as you allow x to go to infinity, this thing goes away, this thing goes away, this becomes 1, and you're left with negative 1 over 2. So that's that limit as it goes to infinity. If you were to change this a little bit though, and just look at the limit as x goes to infinity of sine of x, well, that's a curve that just continues to oscillate back and forth between +1 and -1, and so in fact that limit doesn't exist. Okay, that limit does not exist. So, and just again note that you might have right-handed limits, you might have left-handed limits, but that's just kind of general review of limits. I think that would help you. Another example that we want to do, and we want to turn our attention from limits right now to derivatives. Suppose that you have f of x is equal to sine of x squared plus x, and you want to find f prime. Well, you recall that you need to use a special rule in this situation, and the rule is going to be that you need to use the chain rule. So we have sine of u, we have x squared plus x. I'm going to drop the shade over there. It might be kind of glare for you guys. Sorry if that was frustrating at all. I don't know if it changes. I don't know. It's really hard for me to tell exactly what the light looks like, and kind of looking at my Chromebook, seeing what you guys are seeing. Anyway, we have cosine of u, 2x plus 1. So it looks like we get to, remember, dump the u back in. So f prime of x is equal to 2x plus 1 times the cosine of that x squared. What parentheses run here? 2x plus 1 parentheses around that. Times cosine of x squared plus x. There we go. And so that's your derivative. And that kind of brings up, some of the derivatives that you really should know from this time that we've kind of spent together. For example, the derivative of sine of x is cosine of x. And the derivative of cosine of x is negative sine of x. Hopefully you got those. The derivative of tangent of x is secant squared of x. And the derivative of secant of x is secant of x tangent of x. The derivative of cosecant of x is negative cosecant of x cotangent of x. And the derivative of cotangent of x is negative cosecant squared of x. So those are your 6 that you probably remember pretty well. Hopefully you remember that the derivative of e to the x is e to the x. And the derivative of natural log of x is 1 over x. Hopefully those are ones that you remember. There are a couple more you should remember. Sine inverse of x, the derivative of that is 1 over the square root of 1 minus x squared. The derivative of arctan of x, or inverse tangent of x, is 1 over 1 plus x squared. And the derivative of secant of x is, or secant inverse of x, is 1 over x roots of x squared minus 1. And if you did sine inverse, it's just, or cosine inverse is just negative, cotangent inverse is just negative, and then cosecant inverse is just negative. Notice that the derivatives of all the cos in all situations are negative. That's one of the things that stand out. So you guys have seen kind of some pairings with these over time and kind of see some relationships. If you don't, that's okay. But that's kind of you should know your derivatives. As you enter into Calc 2, they really expect that you either remember them all or you're going to be able to pick up on them pretty easy. My guess is they won't spend too much time going over those. There's just 2 more problems I kind of want to look at for you guys, helping you with a little bit of review. And it's derivative tests. So for example, suppose you have the function f of x is equal to x cubed minus 3x. The first derivative is going to be equal to 3x squared minus 3, and the second derivative is going to be equal to 6x. So what do those derivative tests actually mean? What do they do? If you were to factor out a 3, you get x squared minus 1, or 3 times x minus 1 times x plus 1. Let's think about that graph. the first derivative, so f prime, the first derivative, it's a parabola that goes through -1 and +1. That's what it looks like. What does that mean? That means that this function is increasing from -infinity to -1. This function is decreasing from -1 to 1 because it's below the x-axis here. The first derivative is below. And then it's increasing again from 1 to infinity because it's above the x-axis. Positive, negative, positive. Well, so here, if it changes from positive to negative, that means it goes from increasing to decreasing. So it must have a local max. So local max happens right there. It goes from decreasing to increasing. That must mean it has a local min at +1. And finally, if you look at this one, 6x, that's a line that looks like this. Negative, positive, below the x-axis, above. That means it's concave down here, and it's concave up here, because that's the second derivative. Has inflection point at 0. So concave down, concave up, inflection point here. So those are some important things that we did before that you hopefully remember. Hopefully that coincides with what you know about that graph. It looks like that. As we said, increasing, decreasing, increasing. Local max, local min. Concave down, concave up, inflection point right in the middle. So hopefully that helps. Last one I want to go to is derivatives regarding motion. So suppose that we have this. Suppose we have that a position function is y is equal to -e to the -2x. What is the velocity function? Well, the velocity function is going to be the derivative of that. What's the derivative of that? We'll use the chain rule, and you'll get 2e to the -2x. Then what you can do is find the acceleration function. The acceleration function is the derivative of the velocity function, which is -4e to the -2x. So finally, if it asked you, is the particle speeding up or slowing down at time is equal to 1. Speeding up or slowing down at time is equal to 1. If you remember what we talked about, particles are speeding up if the velocity and the acceleration are same sign. It's slowing down if velocity and acceleration are opposite signs. So let's find v of 1. If we plug in 1 here, e to the -2 power, that's just 1 over e squared. So 2 times 1 over e squared. Well, that's positive, so you get a positive result. Velocity is positive. Here, if you check the acceleration at time 1, you get -4 times, and again, as you plug in 1 there, you get 1 over e squared. That thing is positive, that's negative, so you get a negative result. So in this situation, is the particle speeding up or slowing down? It is slowing down. Why? Because velocity and acceleration have opposite signs. Okay. Now I know that that's a blast from the past. Okay. But as I have this kind of test for you, again it says test, but really it's just kind of a review practice. Okay. Don't worry about it too much. I just wanted you to see some of the basic things we talked about over the past few months that should really help you. I know that if we were all together, it would be easier. This is something I need you to do. It's kind of one of those things we have to check off the list, saying we got through that. And then after that, the following week will be week 5, and we'll be right into finding antiderivatives for the rest of the year, and it should go hopefully really well for you. I miss you guys. I hope you're doing great, and we'll talk to you soon. Have a good one.